This is One-Dimensional Forces Quest Review, problems 5 through 7. Connor and Mattis have loaded up a specially created hay elevator with 202 kilograms of hay. After they start the elevator moving, Connor notes the elevator traveled 15 meters in 4 seconds. What does the scale say the hay weighs during this time frame? Well, we're going to start by putting our given information. We have a mass of 202 kilograms. We know that the normal force is what we're really hunting for. That's what the scale says. And then we've got some more information. The distance traveled is 15 meters, and the time it took to travel that was 4 seconds. So we have that, and it's after they start the elevator moving, so we can infer that VI, the initial velocity, is 0. So I'm drawing the free body diagram over to the right, and I've got a force going down and a force going up, adding my arrows to it, going to add some labels to it. So the force going up is going to be the force normal, or what the scale is reading, and the force going down, of course, is force gravity, or mg. I can go ahead and calculate what mg is, taking 9.8 times 202 kilograms. It should be a negative, so I added that in, negative 1979.6 newtons, and I've put it on my free body diagram. Now I'm going to start summing my x's and y's. There are no x forces, so that side is going to stay blank. On the y side, I have F net is equal to Fn plus Fg. But I don't know what F net is, nor Fn, so I'm going to use my other equation, F net equals ma, to find F net, but I don't know what a is. So I'm going to have to use one of my kinematic equations to find a, so I can find F net, so I can find Fn. With the information I have, I can use dF equals di plus vit plus 1/2 at squared. dF is 15 meters, di is 0, as always. Vit is 0, so then I have 1/2 a times 4 seconds squared. So then I'm just going to solve it for a. So I get the acceleration is equal to 1.875 meters per second squared. So now I can take that and plug it into F net equals ma. So F net is equal to the mass, 202 kilograms, times 1.875 meters per second squared. And I get F net is equal to 378.75 newtons. So I take the value for F net and plug it into my y equation. So F net, 378.75, is equal to Fn minus the force of gravity, which is 1979.6. The normal force is 2358.35 newtons. Problem solved. Back to Coy and her Christmas problems. Coy is unsure if she should use FedEx or a local delivery service for the gifts she ordered. She decides to look at the acceleration rates of the different delivery vehicles. Local delivery service uses a 3563 kilogram mini truck. FedEx uses a larger 7965 kilogram van. Both start out from rest and can deliver the same starting force. What would their individual accelerations be? This is basically two problems. So I want to compare the acceleration of my local delivery truck to my FedEx truck. So I'm going to make a visual graphical organizer and split my paper into two just to do it. This is a multiple choice problem, so I'm not going to really have all the work shown that I would show for another problem that's not multiple choice. But still, the concept is the same. The local truck has a force of 12084 newtons, and the FedEx truck has the same force. Then I write down what their individual masses are. The mass of the local was 3563 kilograms. Mass of the FedEx was bigger, 7965 kilograms. And I'm hunting for the acceleration on both of them. I know my equation is F net equals ma, so the acceleration is the net force, 12084, divided by the mass for the local truck. And the acceleration for the FedEx is the same force, 12084, divided by the mass of the FedEx truck. Plugging it all into the calculator, I get the acceleration of the local truck is 3.39 meters per second squared, and the acceleration of the FedEx truck is woefully behind at 1.52 meters per second squared. Still doesn't say which one Coy's going to use, but that's her problem. End of this problem. And now for that bicyclist and his bicycle. They have a combined mass of 100 kilograms. We want to know what force is necessary to bring him to rest when he is traveling at 18 meters per second to the right, and he must stop to avoid a tree 8 meters in front of him. So we're hunting for the force applied, or the force of friction, you could call it. We know the mass is 100 kilograms, the distance is 8 meters, and his initial velocity is 18 meters per second. We can infer that his final velocity is 0 because we wanted to bring him to rest without hitting the tree, hopefully. I'm going to draw that free body diagram. I have the dot representing the bicyclist and his bicycle. I know I have a downward force of gravity, and he's on a surface. Therefore, I have an upward normal force, so I'm going to draw those in first. Horizontally, or in the x direction, I really only have one force, and that's that applied force to get him to stop. So I'm going to go ahead and draw that in. Since he's moving to the right, the force to stop is going to be to the left. I'm going to put all my little arrows in and put my labels in. I have the force of gravity going down, the normal force going up, and this force applied going to the left, or again, I could call it a force of friction. Next, I'm going to do my x's and y's. On the test, you're going to have to show all the y's. On this particular case, I'm not showing the y's because I was working it fast and I was tired. On the x side, all we have is that applied force, so F net is equal to the applied force, which doesn't help us a lot. We also know that F net equals ma, but I don't have the acceleration, I just have the mass. So I'm going to have to use my kinematic equations to find the acceleration so I can find F net, so I can find the applied force. I'm looking at what I have given. I figure Vf squared equals Vi squared plus 2AD would be my best bet. The final velocity is 0. The initial is 18. My distance traveled is 8 meters, so I fill all that in, and then I go ahead and solve for A using the wonders of algebra. And for A, I get negative 20.25 meters per second squared. Negative, it's going to the left. So now that I have A, I can go ahead and plug that into F net equals mass times A. Mass is 100 kilograms, so 100 times negative 20.25 gives me a net force. We get F net equals negative 2025 newtons. End of problem, end of video. Thank you for your time.